Cemeteries, above all, they're places to commemorate the dead and remember the people who've gone before us. But if you look around at the gravestones, they're a wonderful place to start studying geology. There's a wide range of rock types in every cemetery, and by looking at the rock types, you can learn so much about the history of the earth and how to study science. But oh, here's something different, isn't it? Yeah. What do you think? Sandstone,
this
maybe?
Is, clearly a sandstone. You can see by the erosion, which is caused by rising damp.
Geology is a really great way to learn about science because in its early stages it's largely all about observation, so the only tools you need are your eyes.
In a cemetery you can carry out scientific fieldwork at leisure and at no cost. Just using your eyes you can observe features of rocks like the colour and the texture, but if you have a hand lens you can see so much more. When you first pick up a hand lens to look at a specimen, people's reaction is to do this kind of thing. Of course, what you must do is to put it very close to your eye and then move the object like this until it comes into focus.
And when you get it right, the surface detail suddenly snaps into focus and you can see all sorts of things that you couldn't see with the naked eye.
You're absolutely right, and the thing is, when people get it just right, they always say with surprise, "Ooh!"
They always do. It's this close-up detail that really helps you to distinguish one stone type from another. Now, this is a Victorian cemetery, and the Victorians like to commemorate their dead with elaborate memorials and stones brought in from all over the place. For example, this grave is made of Portland stone, whereas this one is made of Carrara marble. Both were really good for carving and both are white, but if you look at them very closely with your hand lens, you can see that actually they're quite different types of stone.
This is Portland stone. It's a white limestone that comes from Dorset. It was used much in London in the 17th century for the rebuilding of the churches by Sir Christopher Wren, and also by the War Graves Commission for tombstones for the soldiers who were killed in the 2 world wars.
Portland stone was deposited in the Upper Jurassic period. That's about 145 million years ago. It was deposited in warm, shallow seas, such as you find now in the Bahama Banks, and it's made of limestone, that's calcium carbonate. That's the same material that forms the white limescale in our kettles, for example. But in this case, it was a lime mud that was shaken around to form little tiny spheres called ooliths.
The word oolith comes from an ancient Greek word, oon, meaning an egg, and lithos, meaning stone, because the texture of the stone is rather egg-like.
Some people say it looks like semolina, and because Portland stone often contains lots of broken bits of shells from sea creatures, we like to refer to it as semolina with shells. That's a good way of recognizing Portland stone. You see those? Here's another white one.
Yeah, I know. This often confuses people because it's white. So they think, when you've been talking about Portland, they think it's Portland. But here's another stone that was popular in Victorian cemeteries. If it's kept clean, it can look bright white, as it was when it was new. But if it's weathered, it typically takes on a bluish grey sort of colour. Once you get your eye in, you'll see it everywhere. This is Carrara marble. It comes from the quarries in the north of Italy, in the Apuan Alps, and it's been prized over the years by sculptors such as Michelangelo.
Carrara marble originated as a lime mud, or a fine-grained limestone deposited on the seafloor around 200 million years ago. It became a marble when it was changed or metamorphosed as it was subjected to great heat and pressure, in this case when the continent of Africa crashed into Italy, pushing up the Alps about 15 million years ago.
The heat and pressure caused the molecules of calcium carbonate to reorganize themselves into crystals and form a texture of tightly interlocking grains. And seen through a hand lens, they look just like granulated sugar or Kendal mint cake.
Do people still eat Kendal mint cake?
I'm sure they do. It's a fine delicacy from the Lake District. It gives you energy when you're hill walking.
Well, you'll often find in a weathered piece of marble that rain, which is slightly acid, has dissolved the crystal boundaries, and dirt and algae have got in to delineate the individual crystals more clearly. It's these sharp crystal shapes that help you to differentiate marble from the round spheres of an oolitic limestone like Portland stone. Oh, but
What's this
There's
one
something
then?
a bit different here. This is really interesting.
There are many types of
Yeah.
limestone and lots of them are used for gravestones. This particular one is a crinoidal limestone. Probably it was deposited about 340 million years ago.
In close-up you can see it's packed with the debris of the remains of crinoids or sea lilies. In spite of their name, sea lilies are animals, they're not plants, and they're related to starfish and sea urchins.
A crinoid consists of a long, flexible stalk rooted to the seafloor. At the top is the head and body, surrounded by feathery arms which capture particles of organic matter from the surrounding seafloor. The long stalk consists of individual ossicles or elements, each element looking more like a donut with a hole through the middle of it. When the animal dies, all these elements are scattered on the seafloor, and this is what forms the limestone. And if you look very closely or use your hand lens, you can see them quite easily on the surface of the weathered stone.
Because stone is very heavy to move, the older gravestones in churchyards tend to be made of very local stone. But in the 19th century, when the canal networks and the railway networks developed, it was possible to bring in stones from further afield.
Well, here's an example made from Peterhead granite that's quarried near Aberdeen in Scotland. It has a Celtic cross on the top with an intricate strapwork pattern in the panel beneath it. This would probably be a design from a stonemason's pattern book and was popular in late Victorian times.
Granites are igneous rocks. They originate from a magma molten mass buried deep beneath the earth. And as the mass rises very slowly, and we're talking in terms of thousands or even millions of years, the different minerals crystallize out and the rock solidifies. There are many different types of granite, but all have a basic formula. That is around 20% quartz, a mineral composed of silicon dioxide, and it's one of the commonest minerals on Earth. Around 65% is feldspar, another silica-rich mineral that also contains various amounts of potassium, sodium, and calcium. And the remaining 15% is made up of sheet-like crystals of another silica-rich mineral, mica, and even smaller amounts of various metal-rich silicate minerals, and we usually lump them together simply as dark minerals.
The mica tends to catch the light on a sunny day, and you can see them sparkle as you move your head from side to side. Feldspars with a higher content of sodium or calcium are usually white, but the feldspar in this Peterhead granite has a high potassium content, which gives it a pinkish hue. The granite cooled fairly steadily and uniformly so that the crystals are all pretty much the same size.
The differences in feldspars help geologists understand how a particular granite formed. In general, very large crystals mean that the melt cooled very slowly, that is, it rose quite slowly. We're talking in thousands and millions of years. And the smaller crystals are usually when the granite cooled much more quickly.
On this granite gravestone, you can see different types of feldspar crystals on the polished face of the cross. Some are very large, and you can see brown rims. So a granite like this must have formed by several stages of heating and cooling.
This is the kind of thing that really gets geologists and chemists excited. By looking at things like the brown rims on these feldspars, they can tell an awful lot about the formation of the crystal itself, but also the rock and, by implication, the history of the Earth.
Once you begin to get a feel for geology, you realize there are many opportunities for observing and learning from rocks, even in an urban environment like this.
You can find out more by visiting our website and reading our book. One thing's certain, you'll never look at cemeteries in the same way again.